So now you guys know lots of ways to calculate derivatives. It's the only cat who has not been in a video yet. Hey, Kuti. Come here. She wants to get in my bag and go to school. Come here, Kuti Bug. Say hi to everybody. No, we don't want to see your butt. Come here. Yeah, that's Kuti Bug. Okay. Anyway. You know several ways to find these derivatives using the power rule, using sine, derivatives of sine, cosine, e to the x, in using the limit definition. All right, but what we want to talk about this week is like what really is it? What really is this derivative thing, and what can you do with it? Okay, so that's what we're going to talk about first, is the meaning of the derivative. And one way to understand that is in terms of applications, and we're going to look at a couple of applications this week. The first and foremost being motion, which is one of the most important applications of calculus. So let's just sort of be clear about what these things really are. So f of x is a function. All right. Now, so we have this mathematical definition. A function is a set of ordered pairs such that for every x, there's a unique y. All right. So, but in terms of like things you actually do with a function describes something. All right. So it could describe something like the total heat energy of the atmosphere of the Earth, or the total population of the Earth, or the population of endangered species in a forest, or the number of cases of a virus. It describes something, and that's where the functions become useful, okay? And then, in terms of that description, what f prime of x is, it's another function. I'm going to write it that way. It's another function that gives the instantaneous rate of change at any point x. So, or, you know, it could be a point x or it could be a time t, right? So here are some things that means for the graph of f. F prime is the slope of the tangent. Now, remembering that f is a function, it's not a specific value. So like you have a function, and the function has different values at different points, and the slope of the tangent has different values at different points, right? So m is equal to f prime of whatever x value you're at. So if we're at some x value, the slope of that tangent is the f prime of that point, okay? So a lot of times we have our function f represent something that changes in time. If I can separate my pages. Okay, so we could have a function, let me say it this way. A function can represent a quantity that changes over time. And that's sort of like the really general and important aspect of all of this stuff. So just for example, h of t could be a function that represents the heat energy in a system. You know, what I love about mathematics is its generality. Like, it doesn't matter what the system is, the math is all the same. So we could be talking about an internal combustion engine. We could be talking about an electric motor. We could be talking about the Earth. We could be talking about a galaxy, the solar system, anything that has heat energy, the ocean, all right? If h of t could be some function that describes the heat energy in some system. Then what h prime of t is the instantaneous rate of change of heat energy at time t, right? So for example, you know, just to take a really crucial life and death example, say h of t is the total heat energy of Earth's atmosphere, all right, which we're all concerned about. So h prime is how fast that heat energy is changing. So h of t tells us how much heat energy there is. H prime tells us how fast that energy is changing at any given moment. And so, one of the big concerns now is that the rate of change is not constant, it is increasing. So we can then, say things like, if h prime of t is greater than 0, if h time is positive, then that means that the heat energy is increasing. And if h prime of t is negative, then that means the heat energy is decreasing. So I'm just sort of talking conceptually about what these things mean and what they're about. If you have h prime of t equals 0, that means the heat energy is constant. That's something like, for example, you'd like your body temperature to have a derivative of 0. You don't want your body temperature to be changing. You want it to be constant. If the derivative of your body temperature is positive, that means not only you have a fever, but your temperature is rising. So you're getting more of a fever. Actually, you could be hypothermic, and you would want to have h prime of t be greater than 0. So if I have hypothermia, my body temperature is dropped to 70 degrees, I'm unconscious, I want my body temperature to have a positive derivative. I want my heat energy to change. But you might be concerned about the rate at which that happens, because if it happens too fast, you might have some kind of tissue damage or something. I don't know. I'm not a biologist. Do I look like a biologist? I'm a mathematician. All right, so let's just look at some other examples. Let's say P of t equals the population at time t. So, again, about generality. You can be talking about the population of people on the earth. You could be talking about the population of people in Danbury. You could be talking about the population of endangered frogs in the Amazon. You could be talking about the population of the percentage of the population that's infected with the virus. All those things. Then, what would P prime of t represent? P prime of t would represent the rate of change of population. Right? So then you could also, at time t, right, at a time t. So then you could also say things like, if P prime of t is positive, then the population is increasing. If P prime of t is negative, then the population is decreasing. And if P prime of t equals 0, then the population is stable, it's constant. All right, and remember that the P prime value depends on t. So you might have something like at t equals, let's say t was, when was the Black Plague, like 376 AD or something? I just made that up. Then P prime of 376 might be negative because people are dying. But of course, after, presently, P prime of 2020, that population growth, P prime of 2020, is going to be positive. So P prime is a function. It depends on t. It could be sometimes negative, depending on the value of t, sometimes positive, depending on the value of t, sometimes constant, depending on the value of t. All right, so there's just some very general kind of things we can say about that, and we will get more specific next.